Hi there, we are testing here the Funcube dongle versus the DVB-T stick. I'm using INMARSAT C again as a test signal, and as you can see here, the noise baseline is 95 dB. That's currently with the Funcube dongle, and the signal is peaking almost 75 dB. So it's almost 20 dB signal to noise ratio, depending of where you set the baseline, the 0 dB line, if you take the peaks of the noise level or the average noise. The average noise is at around minus 95 dB, whereas the average peaks are probably around minus 93. So it would be something like 18 dB signal to noise ratio, and this is with the Funcube dongle. And you can see only 100 kilohertz bandwidth here. This means if you want to tune to other frequencies or want to see other things, you need to tune it in a different way. There is another data signal here at around 1539,500. And this one is slightly weaker. That's the 80 dB line. That's the 80 dB line. These data channels are slightly weaker than the network control channel I had before. But what is interesting now, I'm going to stop the Funcube dongle. I have in order to make it faster, and I don't need to switch the antennas and the dongles back and forth, I'm going to load a raw IQ file, which I recorded just a few minutes ago, which is from the DVB-T stick. Here you have exactly the same frequency range, but now you see 1 megahertz bandwidth. So I'm going to tune the same signal, which is here, that I had before. We can also zoom in a little bit to make it a bit bigger. So now it's really big, zoomed in, so it looks a little bit like on the Funcube dongle before. And what we see here is we are once again we are a little bit lower with the baseline. It's not at 95 but slightly below. So if you see this, I would say we are at 16, probably 16 dB. Okay, the recording has stopped. Let's start it again. So we are probably at 16 dB over the noise. If you take the peaks, or maybe if you take the average noise line, it's around 18 dB over the noise. So probably 2 dB advantage for the Funcube dongle at best. But at the end of the day, we are receiving the same signal, and the big advantage is this one, that we are getting a much wider bandwidth, and this becomes clearer when I load the other file for the data channels. It's this one. Let's start it. So here you can see a lot of data channels. There are 1, 2, 3, 4, 5, 6, 7 or 8 data channels here in this area, and another 2 data channels here. This is impossible to do with the Funcube dongle. You couldn't see this at once. You would need to tune to the various frequencies, as I have shown earlier. So the wide bandwidth is where the DVB-T dongle really excels, and you can see all these data signals and also tune in here, for example. So here we are. Here's a data signal. Here's another data signal. So theoretically, all these data channels could be demodulated at once which with a Funcube dongle would not be possible, or you would need several Funcube dongles. Okay, so this was a short shootout, and I'm going to try another one on another frequency range in the UHF range, where I'm planning to also compare Funcube dongle versus DVB-T stick.